So in this lesson, I am going to be talking about river and stream erosional and depositional features. As water continues to run over the surface, the unique erosional features, and when it doesn't carry that material anymore and deposits it, those unique features that are associated with the agent of erosion of water. The first one I'm going to be talking about are erosional features. That is when the water moves over the surface and removes the material, what unique things are going to be left behind. Here you can see the V-shaped valley. This is probably the number one asked question on Regents exams when it comes to rivers. The characteristic V-shaped valley, the steep slopes on either side. Here you can see in this picture and also over here. Another erosional feature are what we call meanders. Meanders is a word for that water running over the surface. As time moves on and water continues to move over, it will start to curve and bend over the Earth's surface, and we call those meanders. And that word is going to come back up again when we start talking about another feature called an oxbow. So if water is not carrying material, it is depositing material. And yesterday we talked about we learned how to read the graph in our reference table, page 6, which said that as the velocity increases, the larger the particle and the more material that river can carry. The opposite happens if the water slows down, it can't carry as much. So as the water velocity slows down, the size and amount of material that can carry decreases. So here in this situation, when you're talking about depositional features, you're talking about water slowing down for some reason, and it starts to drop its material, and unique features will start to happen. Here, when the water velocity slows down, when it reaches some quiet water, example of that would be a lake, a pond, or an ocean, the water slows down, and what the river or stream is carrying starts to get deposited in this characteristic unique shape called a delta. For you guys, most famous one that most people remember is the Nile Delta, but here's the Mississippian example, another Mississippi example of the unique shape of the delta, and also here. And you can also see the deposition that's starting to happen as that water moves into this water that's not moving. This is also a delta, which is a stream that comes down into Cayuga Lake, and this over time has deposited and formed the Taughannock State Park that some of us have gone to and visited. Other unique depositional features are levees, floodplains, and oxbows. Levees are when water in times of flooding will rise and move over and spill onto the surface. These mounds of material will start to build up and will help to contain water when water starts to fluctuate during summer season. You might have areas of when the water's high or low, but this helps keep it in there so it's not flooding every single time. Also, what happens over time is a stream or river will start to develop a floodplain. It's the flat area in and around the stream. On our topographic map that we looked at on Owego, that was the area that the topographic contour lines were spaced very far apart, indicating the land being very flat. So making a connection back to that. Oxbows are another unique feature, which is when a stream or river flows over the surface, the longer it flows, the more it will start to meander. And sometimes those meanders will get so curvy that eventually they will break through and the oxbow will be left behind, and the water will continue on a straighter pathway. I have a quick animation for you to look at to watch the development of an oxbow form. So just take a quick look at this. You can see the ball trying to represent water moving and the erosion that takes place on that meander. And this is representing the deposition that's taking place. And once the cut off, vegetation may start to grow, and then you're left behind with this oxbow lake. One of the things we need to remember is water starts to run over the surface. It starts to make the characteristic V-shaped valley. But as the water continually over time carries material, it will start to change the landscape. So here is an example of a landscape that it has water, a youthful stream moving over it. You can see the V shape, the steep slopes, more erosion going on than deposition. But as water continuously flows, the valley starts to widen and a floodplain starts to develop, and this is what we call a mature stream. You can see that floodplain making reference to our depositional feature before. And here's some of the other characteristics that you will see associated with that mature stream. Here, as the water continues to flow over the surface, it really starts to meander around. You get the oxbows and multiple oxbows occurring. Also having these tributaries, which are streams that flow into that water or that stream or that major river. And you can see the big difference, much wider valley here. The V shape has kind of gone away and has widened, and this floodplain has taken over. So review these various characteristics of the youthful, mature, and old age stream, and stop the video. What I would like you to do is stop the video and look at each one of these diagrams, and I would like you to show the river in various stages of development, and using the characteristics that you just reviewed, put them in order, with 1 being representing the most youthful stream photo, and then 2, 3, and 4 being in representing the picture that you believe has the old age stream in it. So if you could stop the video now and answer that, and then when you start it back up, the answers will be here for you. So here are the answers. This, the most youthful diagram, V-shaped valley. Here you can start to see floodplain occurring, valley widening, but you still that V-shaped characteristic there. Here, 3, starting to really meander around, definitely widening of the valley, and here really wide, really meandering over the surface, and multiple oxbows in there. Another erosional feature is headward erosion. When a stream is continuously carrying material, it will start to move backwards, in other words, get longer, and that is called headward erosion. Here's a great picture to show that development over time. You can see the stream moving over, and then that getting longer. Here, this is at the head of the stream where it's eroding and making the stream get longer. And here you can see the last photo. These are other examples of headward erosion that can happen with waterfalls. Here's Niagara Falls. These continuously large chunks of material break off and get carried away and make this waterfall move backwards. So it's actually moving in this direction backwards. The stream is continuously moving the material, however, this waterfall will continue to migrate backwards. And over here, this is Tacanic State Park again, where you can walk up and view these waterfalls, but this waterfall has been slowly moving backwards from the lake itself. That's where it originally was. And over time, it has moved backwards away from the lake, and will keep doing that over time. The quick animation for you to look at. Here you can see what's happening, a side view of the material breaking off, then the waterfall appearing to move backwards. So what I'd like you to do is stop the video and go to the checkpoint question on the next page. And I would like you to answer the questions that have to do with the Niagara Falls, and rate of question where the falls will end up moving to, and a little compass direction question. Please stop, answer those questions, and when you start it back up, I will have the answers and we can talk about them. So here are the answers to our checkpoint. Talking about Niagara Falls, it has been regressing is the word, moving backwards for the last 12,000 years. It has moved 7 miles from its original place. And if you plug that into our rate of change formula, 7 miles over 12,000 years, you can see the rate of movement is 6 miles per year. Seems very small, but that's kind of been a long time, so it makes sense. If Niagara Falls was to continue to go backwards or regress upstream, where would it be in another 10,000 years? So hopefully you put your star in this general location, because here's the current location, and in 10,000 years it's probably going to be back in here, so hopefully your star is back here. What compass direction is that? Some of you may put northwest, and if you did, it's because you were thinking that this part of the diagram was north. If you actually look over here, you can see north is actually pointing to the bottom of this picture. And so this ends up being the southeast direction. So hopefully that didn't get you. So last but not least, here is the drainage basins and divides. Today we're going to be doing a lab activity that will help us more with this, but really all this is the Mississippi is the largest watershed, or has the largest drainage basin, meaning the river itself and all of its tributaries. Any river that connects to the Mississippi, that connects to that is all a part of the Mississippi watershed. And here you can see how large that is. And what separates river systems from each other are what we call divides. Those are a natural boundary, usually a mountain range, that's separating these river systems from each other. And the Great Continental Divide moves through here in North America through the Rocky Mountains, and that helps separate the water that falls on this side of the Continental Divide will eventually make its way into the Atlantic Ocean, and any precipitation that falls on the west side of the Continental Divide will eventually move into the Pacific Ocean, and that's really what the divide is doing, dividing that precipitation. And the Great Continental Divide is the one that separates water from moving into the Pacific Ocean from the water that's moving into the Atlantic Ocean. And like I said earlier, usually associated with some sort of mountain or mountain range. So this concludes our lesson on erosion and depositional features, water changing the landscape over time, our headward erosion, and our drainage basins and divides. So you will be directed by your teacher, me, or Mrs. Riley to work on the River Systems and Divides lab activity that will help you better understand the watershed, the river and its tributaries, and also the divides.